Hey, have you ever felt the warmth of the sun on your face or, grabbed a coffee mug that's just a little too hot? Well, that's heat on the move. And today we're going to pull back the curtain on the three secret, invisible ways heat gets around, forces that are shaping our world all the time, from your kitchen stove to the engine in your car. Okay, let's just jump right in with a question. Picture this. You've got a steaming hot bowl of soup. You stick a metal spoon in it and boom, in seconds, that handle is almost too hot to touch. But the ceramic bowl itself? It warms up way, way slower. So what's going on there? The answer? Well, it's our first big secret of heat transfer. So first up, we're talking about the most hands-on method of them all. It's a process that only works when things are literally touching. I'm talking about the science of direct contact. Now, the official name for this is conduction. And the key phrase to remember here is direct contact. It's just heat being passed from one thing to another by touching. It can happen in solids, liquids, and gases, but it really shines in solids, especially metals, where all the tiny particles are packed together super tightly. The best way to picture this is to imagine the little particles inside that metal spoon are like a long line of microscopic dominoes. When you heat up one end of the spoon, that first particle starts vibrating like crazy. It bumps into its neighbor, getting it to vibrate, which then bumps into its neighbor, and so on, passing that energy right down the line, all the way up the handle. You actually see this in action every single time you cook. The burner on your stove starts that first domino, the particles right on the bottom of the pan. They pass that jiggling energy straight up through the solid metal, and pretty soon, the whole pan is hot enough to cook your food. That's conduction, right there in your kitchen. Okay, so conduction totally explains the hot food, but how does a single little space heater manage to warm up an entire room? For that, we need secret number 2, and this one involves heat basically catching a ride. This method is called convection. Now, this is totally different from conduction. With conduction, the energy just gets passed along from particle to particle. But with convection, the heated particles themselves actually get up and move, carrying their energy with them. This happens in fluids, and in physics, that just means anything that can flow, so we're talking about liquids and gases. The hot air elevator is the perfect way to picture this. When you heat up air, its particles spread out, which makes it less dense, lighter. So just like a hot air balloon, this warm air starts to rise. And as it goes up, the cooler, denser air from above has to sink down to fill the space it left behind. And this shows that cycle perfectly. Your space heater warms up the air right next to it. That warm air rises up to the ceiling. The cool air from across the room then swoops in along the floor to take its place, gets heated up, and then it rises too. This creates this constant circular flow called a convection current, and that's what gets the whole room toasty. So we have heat by touch, and we have heat by moving currents. But what about the sun? It's millions of miles away through empty space. Or what about a campfire you can feel from all the way across the campsite? You're not touching it, and you're probably not in a column of rising hot air. This brings us to our third and final secret. And that secret is radiation. Now, what makes radiation so special, so different, is that it doesn't need any particles or matter to travel. It just moves as invisible energy waves, specifically infrared waves that can shoot right through the total vacuum of space. Yeah, think of it like a radio station, but for heat. The sun, or a bonfire, is the broadcast tower, and it's sending out these energy waves in every single direction. Your skin is like the receiver. When those waves hit you, they transfer their energy to your body's particles, and you feel that as warmth. It's amazing. I mean, we've all felt this. You're sitting around a campfire on a cool night. You're definitely not touching the flames, and the wind might even be blowing the hot air away from you, and yet, you can still feel that intense warmth on your face. That feeling? That's pure radiation at work. So let's do a super quick recap of our 3 secrets. We've got conduction, which is heat by touch, like a hot pan handle. We have convection, which is heat by flow, like the rolling currents you see in a pot of boiling water. And we have radiation, heat by invisible waves, like the warmth you get from the sunshine. But here's where it gets really, really cool. In the real world, these 3 methods almost never work alone. They're usually all happening at once. So let's put on our heat detective hats and see if we can spot all 3 in a classic campfire. Okay, think about that fire. The ground directly under the logs gets hot because it's touching them. That's conduction. The smoke and the superheated air rise straight up in a powerful current. That's convection. And that warmth you feel in your cheeks from across the circle, That's pure radiation. All three working together in perfect fiery harmony. All right, for our last example, let's look at an absolutely brilliant piece of engineering that has to master all three of these principles just to stop a catastrophe every time you drive, and that is your car's cooling system. I mean, just think about it for a second. An internal combustion engine is literally a series of thousands of tiny controlled explosions happening every single minute. The amount of heat that creates is just immense. So, how on earth does it keep from turning into a puddle of molten metal on the highway? Well, it's this really elegant dance of heat transfer. First, conduction pulls that dangerous heat out of the solid engine block and into the liquid coolant that's touching it. Next, convection takes over, as a pump forces that hot liquid to flow away from the engine and into the radiator. And finally, the radiator's fins use both convection and radiation to dump all that heat safely into the passing air. It's a beautiful and absolutely crucial system. And there you have it. From something as simple as your morning coffee to the complex engine in your car and even our planet's entire weather system, these three forces, conduction, convection, and radiation, they're the invisible architects that are constantly shaping the world all around us. So now that you're in on the secrets, I bet you're going to start seeing them everywhere. So I'll leave you with a little challenge. How would you design the perfect coffee mug to defeat all three types of heat transfer and keep your coffee hotter for longer? Think about it. How would you stop conduction? How would you block convection? And how would you reflect radiation? It's a fun little puzzle, and now you have all the tools you need to solve it. Thanks for joining me.